see how can we solve this question. Third B marks. What they have given for the given circuit, calculate the value of capacitor to be connected in parallel. We have to connect one capacitor in parallel so that power factor of the circuit reach unity. Means this is the question of power factor improvement. Okay, whenever we'll have the question of power factor improvement, means earlier there was a power factor, maybe values vary from 0.5 to 0.9, but by addition of capacitor power factor improves to 1. So ideally the power factor should be unity only, but due to the use of inductive load power factor reduces. So ultimately what they want, they add a capacitor in parallel to the existing circuit. This is the existing circuit, just to improve the power factor. Got it? So for these kinds of circuit, we have to draw two power triangle. This one is the first power triangle, this one is the second power triangle. And for the second power triangle is the new power triangle, means with capacitor, right? And this one is without capacitor. So what they have said that after addition of capacitor, the power factor of the circuit reaches unity. Power factor of the circuit reaches unity means cos phi value would be equal to 1. Without capacitor, we don't know the value of cos phi. In both the cases, active power will always remain same. Okay, these points you always have to remember when you will get the question of power factor improvement. First, draw two power triangle. Next, we need to calculate the power factor for both the triangle. This they have already given, but this we need to calculate. Next point, the power, active power for both the triangle should always be the same. Okay, understood? Hmm? Clear? Now our main aim is to calculate the power factor, or we can say phi, without capacitor. So this was the diagram without capacitor. We need to calculate phase angle. Whenever the circuits are connected in parallel, then in that case, how can we get phase angle? By the angle of voltage and current. Okay, voltage angle they have given like 240. They didn't mention any angle, that would be so. Current angle we don't know, but we can calculate current angle. So the angle between voltage and current would be the phi. That what we want to calculate for this power factor. Understood up to here? Now our main aim is to calculate current. This one is the I. Here we can consider it as I1. Here we can consider it as I2. So I would be how much? Total voltage divided by the total impedance. Total voltage is 240 angle 0. Total impedance we don't have, but we can get total impedance, right? Now as you can see, this one is Z1 and this one is Z2. So Z1 and Z2 are connected in series or in parallel? Tell me. Hmm? Z1 and Z2 are connected in series or in parallel? Z1 and Z2 are connected in parallel, right? Can you tell me the value for Z1? Z1 is how much? 40 ohm, right? Z2 is how much? As you can see that there is no resistor. So can we write down simply 0 plus J60, right? So if these two resistance impedance are connected in parallel, that means Z equivalent would be Z1 into Z2 divided by Z1 plus Z2. Correct? Hmm? So Z1 is how much? 40. Z2 is how much? J60. Z1 is how much? 40. Z2 is how much? J60. Can we solve it? Yes or no? So after solving, we'll get the value of Z equivalent. And after getting the Z equivalent, we can substitute here. Then we'll get the value of current. Current after getting, we'll get it in some terms of angle. Then we'll get it at phi. Right? So after getting phi, we'll get cos phi. Now the question is, we should know the active power rules. Right? So as you know, the formula for the active power is P is equal to I cos phi. Here V is the voltage, that is they have given 240. I is the current that you have just calculated by this formula, so you can put it here. Cos phi is again just calculated by the angle, correct? So active power also will get it. Now we need to calculate reactive power for both the triangles. How can you get reactive power? Tan phi is equal to Q by P. So this phi is different, this phi is different. This phi is how much? Phi is equal to cos phi is equal to 1. So phi would be equal to 0. So in this case, reactive power would be equal to 0 because Vi sin phi sin 0 is 0. But this Q2 will you will get it. This is Q1 you can consider. So the final reactive power is equal to Q minus Q1. Okay. Then you will get some reactive power after solving it, and Q new would be equal to V square divided by XC. Voltage is given 240 ka square. XC we can get it. Q we already know by this method, right? And XC formula is equal to 1 by 2 pi FC. So from here we'll get the value for the capacity.